this video, we will discuss about count unguarded cells in the grid. You are given two integers m and n representing a zero-indexed m cross n grid. You are given two 2D integer arrays, guards and walls which represent the position of the ith guard and jth wall respectively. A guard can see every cell in the four cardinal directions, north, east, south or west, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. So what they are saying is that in the input, we are given m and n, which denotes an m cross n grid, which is this 4 cross 6, right? Then you are given two 2D integer arrays, guards and walls which represent the position of these guards and walls, right? So through these, let us quickly mark the position of guards and walls over our grid. So first guard is present at 0, 0, which is this cell, right? Then next guard is at 1, 1, which is this cell. Next guard is at 2, 3, which will be this cell, right? Then let us mark the walls. So the first wall is present at 0, 1, which is this. The second wall is present at 2, 2, which will be this. And the third wall is present at 1, 4, which is this, right? And all the other cells are empty. Now, what you need to do? So see, a guard can see in all the four cardinal directions, meaning this guard can see all the cells above it, all the cells below it, all the cells towards the left and all the cells towards the right. But in all these directions, if there comes a wall or a guard in between, then in that case, the guard cannot see the further cells, right? So if you see for this particular guard, I said it can see the cells on its right unless obstructed by another guard or a wall, right? So it can see this cell, it can see this cell, but here now it is obstructed by a wall. So this particular guard cannot see this cell, right? Similarly, if we see for this guard can see this cell, it can see this cell also, then this cell also, but towards the left, since it is obstructed by a wall, this guard cannot see these cells, right? So now what we need to do is that we need to find out that how many cells are there within this grid which are not guarded by any of the guards, right? So basically, whatever cells are not watched by any of the guards, that count you need to find out and return as your answer, right? So what we can do, if we start with first guard, then we go to the second guard, then we go to the third guard, and what we do is we start with the first guard, right? We go in the above direction and see that how many cells this guard is able to see, and then we mark them that okay, these are guarded cells with this particular guard, right? So here, since there are no top cells, so we can ignore this. Then we can go towards down, right? So towards the down, this guard can see this cell and this cell, right? So all these three can be marked. So if I mark them, so these will be marked, right? Then if we see towards the left, then there is nothing. And if we see towards the right, then there is a wall. We cannot go further. So then that means this guard can guard these cells, right? Then same process if you will do for this guard. Then above there is a wall, it cannot see anything. Below it will see these two. Towards the left, it is already seen, but you can again mark it. That won't create any difference, right? And towards the right, it will guard only these two cells because there is a wall in between. Then for this guard, again, from top, it will be guarding these two cells. Below, it will be guarding this cell. Towards the left, there is a wall. And towards the right, it will guard these two cells, right? Now you can see that how many cells are there which are not guarded by any of the guards? 1, 2, 3, 4, 5, 6, 7, right? So that means in this case, our answer is going to be 7, right? So simply what I said, that we will take one guard and we will go in all the four directions and we will keep on marking. We will keep on marking the cell as guarded unless a wall comes in between or another guard comes in between, or we reach the end. We reach the boundary of the grid, right? Simply that we are going to follow. So let me just quickly clear this grid out. So see, what you can do is that since in the input you are given m, n and position of guards and walls, we can create a vector by ourselves, a 2D vector or a grid of size m cross n, and we can keep all the initial values as 0, right? So in this particular grid, we will be having 4 distinct types of integers. Now what are we going to denote it? So see, 0 will denote an unguarded cell. Okay, 0 will denote unguarded cell. 1 will denote a guarded cell, right? 2 we can denote for the guards, and 3 we can denote for the walls, right? So initially we have kept all of these as 0. Let us quickly mark the position of guards with 2 and walls with 3, right? So what will happen? So guard is present at 0, 0, 1, 1 and 2, 3, right? So this will be 2, 2 and 2. Then let us quickly mark the position of walls. So it is 0, 1, 2, 2 and 1, 4. So it will be 3, 3, right? Now what we will do is, we will iterate inside these guards. We will iterate inside these guards and we will take one guard at a time, and we will move in all the 4 directions, right? So this will denote you the row and this will denote you the column, right? So what you will do is that first you will move in row plus 1 direction, right, until you reach the end, or in between there is some another guard or a wall, right? So basically from row plus 1 till m, right? And the other direction will be above, so it will be row minus 1 till 0, right? Then other direction is left, so it will be column minus 1 till 0, and next direction is towards the right, so it will be column plus 1 till the end, right? So these are the 4 directions. So you will keep on looping. First you will loop for this direction, and then in this range, if there is any case when row comma column this becomes equals to 2 or 3, that is other guard or wall, then you will break your loop there, right? Because that particular guard cannot see further cells, right? So what we will do is, for this we will go towards the top, but there are no cells, right? Because it should be within this range, right? Then if we see below, then we can go row plus 1, so its row is 0, so it can go 1, 2 and 3, right? And the column is 0. So these 3 positions we will mark 1, 0, 2, 0, 3, 0, right? So what will happen is that we will mark all these 3 with 1, right? Because 1 is denoting that it is a guarded cell now, right? Then you will see towards the left, then it is not within the range. Then you will see towards the right, but as soon as you will enter your for loop, there is a 3 present over here, so you will stop here. For this guard we are done. Then we will go to this guard from here. Now our row and column is 1, 1. Then again you will go towards the top, but there is a wall. You will break out of your loop. Then you will go towards the left. So okay, this is 1. It will be overwritten with 1 again, right? Then you can go towards the right. So the order doesn't matter. You can start from top and then bottom and then left and then right, or reverse or anything. That order does not matter, right? Then towards the right, when it will go, it will mark these 2 cells, and then here a 3 is present, so we will break out, right? Then if we go towards the bottom, so these 2 cells it will mark, and then it will reach the boundary, right? Then we will see the next one, which is this 2, 3. It will go above. So this one is already marked. It will be overwritten, and this will also be marked, right? Then if we see at the bottom, so this will be marked. Then if we see towards the left, so there is a wall, so it will break out of the loop. And then towards the right, it will mark these 2, right? Now what you can do is, after you are done with the guards, you can simply iterate inside this grid and you can check that what all cells are there which are having their value as 0, because 0 is denoting the unguarded cells. So we go in this direction, right? And you will check it. So 1, 0, 2, 3, 4, 5, 6, 7. So your answer will be 7. Okay, so let's quickly code it out. So first of all, we will be creating a grid which will be a vector of vector, right? And we will keep it as integer. The name will be grid. What will be the size? M cross n, right? So it will be n, and initially we will keep all the values as 0, so it will be 0, right? Then we need to mark the position of guards and walls inside grid. So we will traverse inside guards. So for auto guard in guards, then in the grid, add the position guard of 0, comma guard of 1. We will update it to 2, right? And we will update the walls. So for auto wall in walls, and then in the grid at wall of 0, comma, wall of 1, we will update it to 3. Right? Now we need to mark the guarded cells, right? We have marked the position of guard and walls in the grid. Now we need to mark all those cells with 1 which are guarded by all the guards, right? So we will take one guard and we will keep on marking the guarded cells. So for that, let us create a helper function. So what we will do is, we will create a helper function. So this will take three things: row, column and the grid, right? So it will take a row, then it will take a column, and it will take a grid which we will pass by reference. So row and column will denote the position of the current guard, right? Now we will move in all the four directions. So first we will move in the top direction. So we will do int r equals to row minus 1, while r is greater than equals to 0, r minus minus, right? Now inside this you will check that if grid of r comma col is equals to 2 or grid of r comma column is equals to 3. In this case, we will break out of the loop because now it is obstructed by a wall or another guard, right? Otherwise, we will keep on marking these cells. So grid of r comma column will be equals to 1. Then we will move towards the bottom. So it will be r equals to row plus 1, r less than grid dot size, and r plus plus, right? Inside this again we will do the same thing that we did above, that if grid of r comma column is equals to 2 or 3, then break, otherwise mark it with 1. Then let's move in the left direction. So it will be int c equals to col minus 1, c greater than equals to 0, and c minus minus. Inside this we will check that if grid of row comma c is equals to 2 or grid of row comma c is equals to 3, then break. Otherwise keep on marking grid of row comma c equals to 1, right? And then we will move towards the right. So for int c equals to column plus 1, c less than grid of row dot size, right? Grid of row dot size, c plus plus. And inside this we will do the same thing, that if grid of row comma c is 2 or 3, then break, otherwise mark it with 1. So this helper function will help us mark all the guarded cells, right? So coming back here, what we will do is that we will iterate in the guards once again. So for auto guard in guards, and we will call the helper function. We will pass the position of the current guard, which will be guard of 0, comma, guard of 1, and the grid. So this will mark all the guarded cells. Now we need to count the unguarded cells, right? So we will take a count variable which will be 0 initially. Then we will loop inside the grid. So for auto row in grid, and then we will iterate in all the row one by one. So for auto cell in row, and then inside this we will check if cell is 0. If the cell is marked as 0, then we will count it, right? And at the end you can return the count. So this is the approach that we have followed. We can also apply depth first search here. So complexity wise both the solutions are same. This is the approach that I have followed. So let's run it once. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.